Hello everyone and welcome to this presentation, which is going to provide an overview of the main types of haptic interfaces, and in particular comparing the wearable devices with respect to the desktop devices, which are the ones which need to be put on a table or a desk, or in other words, that cannot be worn by a human. In particular, we are going to first focus on the two different types of human haptic perception, which are the kinesthetic and the cutaneous one, because these two perceptions are strictly correlated with the type of grounding of a haptic device that you may desire in order to provide a different kind of feedback. Then we are going to focus more on the disadvantages and advantages of the wearable devices compared to the desktop ones, and then we're gonna see some examples of different haptic interfaces related to their application. And as I was saying before, we have two main types of human haptic perception, which are the kinesthetic feedback and the cutaneous feedback. The former refers to the joints and the muscles of your body. That is, you perceive a kinesthetic feedback whenever a force or a torque is resisting to your movement. So of course what you have is that this is strictly correlated to the type of devices which are able to apply forces and torques in order to resist your movement. So of course the desktop ones. Well, instead, the cutaneous feedback, on the other hand, is connected to the perception and the sensation that you feel on your fingertip, for instance, and so related to the mechanoreceptors which are under the skin. And so, of course, instead, this is much more related to the vibrotactile information, which can be easily provided also with a wearable interface. The type of feedback that an interface is able to apply is strictly correlated with the grounding of the interface itself. Indeed, there are three different types, which are the grounded devices, the handheld devices, and the wearable devices. As we understand from this picture, what we have is that wearable devices are much more small and less complex with respect to the grounded ones. But of course, depending on the application and on the feedback that you would like to provide, you have to consider all of these different haptic devices. So let's go more into the details. The desktop interfaces, as shown in this picture, are the ones that, due to their size, weight, and structure, cannot be worn by a human, but need to be placed and grounded to a surface or a wall or something like this in order to be used. And they have a really high accuracy and are really capable of providing a kinesthetic feedback and also a cutaneous feedback. So of course they have a higher cost, but on the other hand, they are really accurate, so they can be really used in the type of applications, as for instance the medical surgery or something like this, where you really need to be accurate and you don't need a huge workspace. The handheld interfaces are quite in the middle between the wearable and desktop ones, and are the ones that can be worn but need also to be held with your hand, as the name says, and so are probably the happy medium, let's say, between the portability and accuracy. Eventually, we have the wearable interfaces, which are further divided into two categories, mainly, which are the exoskeleton systems, which are able to render the kinesthetic feedback, and so also to apply forces and torques which opposed to the muscles of your fingers and hand, and instead the finger-worn haptic devices, which instead rely on the cutaneous feedback. So are only able to apply that kind of feedback with no instead kinesthetic one. By focusing on the different advantages and disadvantages of the wearable interfaces compared to the desktop ones, what you have is that, of course, the main advantage is the portability, because a desktop interface cannot be worn by a human and is fixed, of course, to a surface or a wall. Moreover, what you have is that wearable interface is less expensive and less complex, and has a larger workspace, which refers to the area in which you can move. On the other hand, you have a massive disadvantage of the realism, because of course desktop interface is much more able and to provide an accurate feedback, and moreover are difficult in rendering the kinesthetic feedback, because of course with the exoskeletons you may provide a certain kind of kinesthetic feedback, but it cannot be as realistic as the one provided by a desktop interface. Let's now see some examples in order to better understand the different interfaces. So here we have the desktop Haptic interfaces provided by the fourth dimension. And in particular, as we can see, the hand is placed on the end effector of the device, and depending, of course, on the version of the interface, it is able to apply both cutaneous feedback and kinesthetic feedback. This video shows an application of this kind of interface, which is really accurate, and so it is perfectly suitable for a medical application. And for instance, here is applied on surgery. Here, why is the haptic feedback fundamental? Because of course you need to perceive a kinesthetic feedback in order to understand the forces and the resistance that the body, and all the mechanisms involved are providing. Otherwise, you cannot operate in a safe and accurate way. So, as we can see, the human places his hands on the effector of the device and is now able to operate at a distance, having the kinesthetic feedback, which in this kind of application is a fundamental thing. This video shows instead another device, which is a scale 1 provided by Option, where instead we can see that this is of course a huge complex systems developed in order to be applied to a virtual reality scenario, in which of course you don't necessarily need a portable device. If on the other hand your purpose is to provide a haptic feedback referred to the tactile sensation of the fingers in a virtual environment as a texture, temperature, or vibrations on the fingertip, of course what you need is a WeArt wearable haptic interface, which is an interface which is much less complex to the one previously seen, and which allows you to provide a cutaneous feedback opposed to the kinesthetic one, which we saw before. And here, as we can see, the user is perceiving the textures provided in the virtual environment, also related to the variations that they cause, the temperature, and all the sensations that you can feel with your hand, providing a realistic interaction with the environment, but of course just cutaneous feedback. So here we do not have any kind of kinesthetic feedback. So from that point of view, of course, this application won't be realistic. And with this, I'm ending my presentation, and thank you for your attention.